Good afternoon, and thank you for connecting with the Pennsylvania Game Commission today. My name is Lori, and I will be managing the session today. We are fortunate to be joined by Dr. Christopher Rosenberry, the Deer and Elk Section Supervisor for the Game Commission, and Duane Diefenbach, an adjunct professor at Penn State, and some of his colleagues. We expect the presentation to last about 30 or 40 minutes, followed by a question and answer period of about 10 to 15 minutes. You can ask a question by typing into the Type Question Here box on the GoToWebinar control panel at the right of your screen. For those of you dialing in to listen by phone today, please note that this is not a toll-free call and you may receive long-distance charges from your service provider. And without further ado, I'm going to turn it over to Duane, who is kicking things off this morning. Thanks for joining us today, Duane. Is there anything you'd like to share about yourself before we get started?
Sure. My name is Duane Diefenbach. I am the leader of the Pennsylvania Cooperative Fish and Wildlife Research Unit at Penn State. The co-op unit is a cooperative of the Pennsylvania Game Commission, Penn State, the U.S. Geological Survey, who is my employer, and the Pennsylvania Game Commission. And so the research that we're going to be talking about today is a 3-year project that was done collaboratively between the Game Commission and the co-op unit at Penn State. And we're going to be talking about not only fawn survival, but the predators that eat fawns. And it's a very appropriate time to start this or to give this presentation, because right about now, about half the fawns have been born for 2018. And most fawn births will be finished by late June, early July. So this research was begun in 2015, and we had 3 field seasons. And our presentation today is going to consist of 4 speakers. I'm going to start off giving a presentation, a little bit of background about fawn research and predator research. Following that, Tess, Gingery, who recently finished her master's degree here at Penn State and studied the fawn survival, will talk about what percentages of fawns survive, causes of mortality, and how survival has changed since 2000 and 2001, which was the last time that the Game Commission conducted a fawn survival study in Pennsylvania. Following that, Asia Murphy, who is a PhD student at Penn State, will explain some of the findings that she's found using camera traps to look at where predators occur, how abundant they are, and how they use habitat and space and time relative to fawns and adult deer. And then finally, we're going to wrap things up with Dr. Chris Rosenberry, who's going to talk a little bit about the management implications of this research with regards to how the Pennsylvania Game Commission makes deer management decisions. So our studies, we actually had 2 study areas, a northern study area located in north central Pennsylvania. In the map you see in front of you, this is the Susquehannock State Forest in green. The dark green is our study area, which was probably almost 100 square miles in size. Just to orient you, Route 6 goes across the very northern tier of the big woods in Pennsylvania. Just east of this map just west of this map would be Coudersport and Wellsboro to the east. So that was our northern study area, typical big woods habitat, 98% forested. The other study area, the southern study area, was located in central Pennsylvania, near State College. We actually had 2 separate areas, but they're both very similar types of habitat for central Pennsylvania. Again, in this area, we're in the Ridge and Valley region. The one study area on the left here was on Rothrock State Forest. The area in green is the forest boundaries. The dark green area is the study area. And then just to the east of, or east of 322, in Bald Eagle State Forest was the second study, or second part of that central study area. And you can see that area in dark green. Again, both these areas are mostly forested, but we did capture fawns in the southern area outside the state forest land surrounding these dark green study areas. So Pennsylvania is the only state that has studied fawn survival in 4 different study areas at 2 different time periods. And so in this graph to the right, you can see the series of basically a cumulative count of the number of fawn studies that have been conducted in North America. And the 2 red dots represent when Pennsylvania conducted its research. You can actually find fawn survival studies going back to the 1960s and 70s and 80s, but it wasn't until the 1990s really that technology improved, where we're able to monitor fawns reliably and get good estimates, accurate estimates of survival. So as of 2018 in North America, if you tally up all the fawns that have been captured and monitored, there's been over 2,500. In fact, 2,649 fawns have been monitored. Pennsylvania, with the 2 studies that we've conducted, we have captured a total of 383 fawns, which represents 15% of all fawns that have been studied in North America. As I mentioned, the technology in the 1990s improved. We were able to have smaller batteries and smaller electronics. And actually, for the 2000 study that we did in Pennsylvania, we actually designed a collar that's used today by most manufacturers when they build radio collars to monitor fawn survival. So sorry about that. So we're not going to just talk about fawns today, but we're also going to talk about predators. And the 3 main predators in North America for white-tailed deer are the black bear, bobcat, and the coyote. Now, there's been a number of other predators that have been documented as killing fawns: fox, wolves, mountain lions, and have all been documented. Even fisher, although it's interesting, even though almost over 2,500 fawns have been radio collared, not once has anyone documented a fisher being killed, one of the radio collared fawns being killed. So it does occur, but it appears to be extremely rare. So with that sort of introduction to the history of white-tailed deer fawn survival research, I'm going to turn it over to Tess Gingery, who's going to talk about fawn survival and their causes of mortality.
Hello, everyone. My name is Tess, like Duane said, and I'm super excited to talk to you guys about what I basically worked on for the last few years of my life and just give you a quick overview of what we found. So I'm going to start off my talk by talking about the current fawn survival, this study that Duane was just mentioning that occurred from 2015 to 2017 in the northern study area, which is the Susquehannock North and South State Forests, and then in the southern study area, the Rothrock and Bald Eagle State Forests. And then I'm going to move into comparing how the previous study who studied fawn survival in Pennsylvania that occurred in 2000-2001, how their survival rates that they observed compared to our current survival. Now, back in 2000, they also had 2 study areas, which were in the Cohanna Wild area and Penns Valley. So when I'm comparing the past and present survival rates of fawns, I'm going to keep the comparison between the Cohanna Wild area and the current northern study area because they're in a similar geographic region, and then also compare Penns Valley to the current southern study area because they are also much closer and more comparable in their region. Before we get into some of the main results that I found, I just want to classify the three main sources of mortality and how we kind of combined them into categories, because there are a lot of ways that fawns can die. So first off, the obvious one would be predation, right? Like Duane mentioned, black bears, coyotes, and bobcats. A second source of mortality would be humans, and this would be both direct and indirect causes. So direct would be, you know, you were hit by a car, you were harvested. Indirect would be the fawn got tangled in a fence and died. And the third source of mortality is natural sources that exclude predation. So this is your starvation, disease, and abandonment type of deaths. So just to orient you guys in space, this is our current study areas, the northern and the southern, and the outlined areas on this map are the wildlife management units that were designated by the Pennsylvania Game Commission. So survival was similar between our study areas. On the left here, you see the survival rate of the fawns through 34 weeks of life there on the bottom. And in the northern study area, survival through the hunting season was a 0.4, but survival was slightly higher in the southern study area, about 0.51, likely because there's more agricultural land cover. So from previous studies, we know that agricultural land cover is positively associated with fawn survival, and so that might have caused a little bit of a bump in fawn survival there in the southern study area. But overall, survival was very similar between the areas. Now, a large review of large herbivore neonate survival, or basically the survival of their young, showed that most mortality occurs in the first 8 weeks of life. They're very vulnerable at this time, and a lot of this mortality is due to predation. And this is reflected in our study. You can see that that survival rate drops down most drastically in those first 8 weeks of life. And in Pennsylvania, most of the human-caused fawn mortality occurred around this window, about 25 to 30 weeks old, depending on when the fawn was born. And most of this human-caused mortality is due to hunting. So what's killing our fawns? On the left here, you again see the northern study area. On the right, you see the southern study area. So in the northern study area, we captured 82 fawns, and there were 44 total mortalities. And in the southern study area, we captured 83 fawns, and there were 38 mortalities. Breaking this down by causes, we see that predation was the main source of mortality, and this is very common. For fawns across North America, predation is the #1 source of mortality. And when we break this down a little bit further, humans, when you look at the human causes of mortality, again, harvest is the #1 cause of mortality, with 6 human-caused mortalities in the north and 5 human-caused mortalities in the south. Moving into breaking down the predation, in the northern study area, there were 33 predation events, and 18 of those were caused by black bears, and so they were our #1 predator in the north. And in the southern study area, we see it was pretty equal between bears, coyotes, and bobcats, but coyotes did become the primary predator there. So moving into our comparisons from the 2000 study, you can see how close in space these study areas are. Again, we're comparing those two northern study areas up there, the little blue square with the green triangle, and then again in the south, kind of they're in the same wildlife management unit. They have similar different weather patterns and geographic regions. But what has changed since 2000? So since 2000, predator densities have increased by 40% statewide, and deer densities decreased around 20% from 2002 to 2005, and have increased or remained stable depending on the wildlife management unit that you're looking at. So we were really interested to see how fawn survival has changed between these 2 points in time. So let's first consider those 2 northern study areas, the Cohanna Wild area and the northern study area. So we're looking at 34-week fawn survival here, and we can see it's very similar. Now, 34-week survival brings you about to January sometime in January, depending on when the fawn was born. And so that brings you through the hunting season. So we can see again, they're very similar. And if we look at their causes of death, predation was the leading source of mortality back in 2000, with black bears being the primary source of predation. Predation was again the leading source of mortality in the current study area. And again, black bears were the primary source of predation. So there's a lot of similarities there. Back in 2000, predation accounted for about 70% of the mortalities and about 75% in the current study. So turning our attention to those southern study areas, Penns Valley back in 2000 and the current southern study area. Again, we see that 34-week fawn survival being very, very similar here. And if we look at their causes of mortality, humans were the primary source of mortality back in Penns Valley back in 2000, with roadkill and harvest being your top two sources of mortality. Now, predation was the primary source of mortality in the current study area, with coyotes again being the primary source of predation. So one difference between Penns Valley and the southern study area was that Penns Valley had a little bit more agricultural land cover in that area. And so sometimes when you have agricultural land cover, it can influence where your sources of mortality are coming from, which might explain why human-caused deaths were the largest source of mortality back in 2000. But ultimately, the no differences in fawn survival between study areas currently and no differences between 2000 and now is a good thing. Studies have shown that when fawn survival changes a lot over time, it can influence population growth rates. But since Pennsylvania fawn survival shows little change over time, this means that it's probably pretty stable, and this is a definite good thing for managers and everyone else. And so that kind of concludes what I've looked at. Overall, my master's work here at Penn State, and I appreciate you guys listening to me. And so next up, Asia is going to talk a little bit more about the predators in Pennsylvania.
Hello, everyone. This is Asia Murphy, and I will move on to the predators in Pennsylvania. So what we did was camera trapping surveys for carnivores in these state forests. And if you look at this picture, you can see that there is, in fact, a camera on this tree. We had 100 cameras, and we used scent attractants to lure carnivores to these camera sites. We spread these 100 cameras over 3 state forests, Susquehannock in the north, Bald Eagle and Rothrock in the south, during the summer. So we ran these camera surveys from May to about early mid-September, from 2015 through 2017. And this is just a basic summary of what we found. So if you look on the left, the y-axis, this is just the number of times a carnivore was detected by our cameras. And we can see that raccoons were actually detected the most out of the 10 species of carnivores that we saw on the cameras. Out of the 3 carnivores that we're focusing on, the bears, coyotes, and bobcats, we actually saw bears as the major detected carnivore, so around 700 detections. And fawns, we actually detect them more often than those 3 carnivores, so that was around 800 detections. And again, this is just some summary information. So we ran these cameras for over 17,000 trap nights or 24-hour periods. There are about 339 total camera stations. And as for total number of pictures, we got over 200,000 pictures. And so this is just a graph to show how many sites out of the total number of sites that we surveyed, certain species were detected at. So starting with bears, we see that we detected them at 64% of our camera sites. And this is just raw detection information. So we're not taking into account areas where bears probably were there, but we just didn't see them on our cameras. This is just raw detection information. For coyotes and bobcats, about similar percent of cameras detected at, 36% for coyotes, and then 33% for bobcats. As for deer, we saw them about all of our camera sites. If we put a camera out, we would see a deer, basically. 97% of our camera sites had deers being detected at them. And as for fawns, we saw them about 44% of our camera sites, so about half of them. And you can see from this red line that means that we saw more fawns at more camera sites than compared to coyotes or bobcats. And so, as I mentioned earlier, again, cameras just take, you just get a picture of an animal, and an animal could be present at that site, but if you don't get the picture of it, you don't know if it is actually present or not. So taking into account animals we missed, we put this data into some occupancy models, and we got these estimates here. So we see for bears, just for the southern region, this is bald eagle and rock right here. So for bears, we saw them again, 64% of the camera sites were occupied by bears. So this is taking into account areas where we didn't see bears compared to the last slide. As for coyotes, we saw them, they occupied 42% of the camera sites. Bobcats, they jump up from 33% of the camera sites where we detected them out to 60% of the camera sites being occupied. So that means that about half of the camera sites where they actually were, we just didn't see them on the cameras. And as for fawns, we stay around 47% of the camera sites being occupied. And if you're interested in what these gray bars are on the colored bars, those are just measurements of accuracy. So just showing how precise and accurate our estimates are. So going into habitat use, comparing the probability of black bear use compared to non-forest and forest sites, we see that black bears really love the forest. We have a much higher probability of bear use at forest camera sites compared to non-forest camera sites, close to about 80% probability. But we see about the same estimate of deer use at these forest camera sites. So comparing black bears and deer, we see that both species tend to not use the non-forested areas, and they tend to use the forest areas more often. Now, what about fawns? Well, we actually see the opposite usage pattern. So we see the probability of fawns using forest areas at around 30% compared to non-forested areas, which is around 90% probability. So what this means is that does are actually using these non-forested areas in the southern region, these ag lands, these fields, to raise their fawns, because it's actually safer for the fawns to grow up in these ag lands until they're old enough to be able to escape the predators. And this actually harkens back to Tess's result, where it showed that you had more mortalities up in the northern study region and more mortalities by predators in the northern study region compared to the southern study regions. And just to show, there's some stories about these does on our Deer Forest Study blog, and you can actually see that this doe actually will move from the state forest, which is on the lower half of the screen, into non-forested areas during the summer, and presumably she'll raise a couple of fawns, and then once the summer ends, she'll start coming back towards the state forest. So just some takeaway points. Deer are basically everywhere. You put a camera out, you're probably going to get a picture of a deer, and fawns are at about half of our study sites, half of our camera sites. Predators love the forest, but so do deer. And this is just for adult deer, of course. You see the same pattern of usage between non-forested areas and forested areas for black bears and adult deer. And of course, does are being smart and using these non-forested areas in the southern study regions to raise their fawns because they know that's safer. And I'll turn it over to Chris.
Okay, thank you, Asia. So to this point, we've covered background information and results from our field studies, and now I will conclude the webinar by looking at how do these results affect deer management. First, let's review what we've learned from field studies in Pennsylvania. We've learned that in forested areas, predators are the #1 cause of fawn mortality, and more often than not, black bears are the predators taking fawns. Second, fawn survival is consistent. In this graph, the squares represent the northern study areas, the diamonds represent the southern study areas, and you can note how the symbols overlap for each area. And in fact, you can barely see the blue squares from the 2000-2001 northern study area because they are so similar to the results from our current study. And these results clearly demonstrate the consistency in fawn survival over time. And finally, from our other field studies in Pennsylvania, we have learned that adult survival is also consistent across the state. Around 90% of deer will survive from one hunting season to the next hunting season. Consistent survival rates create a more straightforward deer management situation in Pennsylvania than in other areas where survival varies from year to year. Because of this consistency, we can more predictably manage deer population trends by adjusting antlerless harvest. So from our field studies, we've documented the effect of predators on fawns in Pennsylvania, and we include predator impacts as part of the Game Commission's deer management program. Each year, we monitor fawn-to-doe ratios in the harvest. When these data are collected during the firearms season, most predator mortalities have already occurred. As a result, fawn-to-doe ratios in the harvest represent the fawns that survive predators. If predators take more fawns, the fawn-to-doe ratio should decline. To answer the question of whether predators are taking too many fawns, we look at deer population trends. Predators are taking too many fawns when deer population trends are below objective. In Pennsylvania, there is no evidence that predators are taking too many fawns in any of our 23 wildlife management units. On this slide, dark green units represent those with increasing deer populations. All other wildlife management units have stable deer populations. If predator impacts are too high, management options are limited, but some can be effective. Often, the first thought is to control or reduce predator populations. Unfortunately, these actions are often not effective for many reasons. For example, in Pennsylvania, most deer hunters do not support reducing bear populations to increase deer numbers. As a result, reducing bear populations would be difficult from a social perspective. Second, although most deer hunters support reducing coyote populations, having an effect on coyote populations is difficult. At present, hunters can hunt coyotes 24 hours a day, 7 days a week, 365 days a year, yet coyotes continue to do well in Pennsylvania. These two examples show the social and biological changes associated with attempting to control predators for the benefit of deer populations. Fortunately, there is one wildlife management action that can be effective should predator impacts become too high, and that is adjustment of antlerless deer hunting opportunities. All across Pennsylvania, reducing antlerless deer harvest will increase deer populations, even in WMUs with abundant predator populations. If deer population trends are below objective, the most effective method to increase deer numbers is to simply reduce antlerless deer hunting opportunities. In conclusion, predators do and will continue to kill fawns, and there is little from a predator management perspective that can be done. From a deer management perspective, our current deer plan is designed to monitor predator impacts, and if predators are taking too many fawns, the deer plan is designed to adjust deer harvest as needed to ensure sustainable deer populations. And with that, I believe we have time to take some questions.
Yeah, thank you. That was a lot of really good information. So we do have some questions, and for those of you that have questions and haven't asked them yet, you can simply type them into the Ask Question Here box in the GoToWebinar panel on the right of your device there. So let's see. We have one here from Mike. Mike asks, how exactly did you know which predator killed the fawn?
Oh, I can answer that. This is Duane Diefenbach. So when we have when a radio-collared fawn is killed, the caller transmits a signal, and our field technicians go to the site to collect information. And from that, you can collect clues. You can see hair, footprints, scats. They might see bite marks. Some animals are more likely to cache the carcass. Bears may just eat the whole thing. But coyotes and bobcats may cache them. We also retrieve the carcass and bring it back to the animal diagnostic lab at Penn State, where the Game Commission's veterinarian does a necropsy, and we can do further investigation of the cause of mortality. Also, we have the field techs would collect DNA. They would swab bite marks and the collar, and we would send those swabs off to a lab to see if we could identify DNA of the predator species.
Thanks. Let's see. Charlie has a question also about identifying predators. He's wondering is there a way to tell the difference between, say, a free-ranging dog and a coyote?
That's a great question. Oftentimes that's very difficult to do. A lot of studies simply identify the predation as canid, and they don't differentiate between dog and coyote. In Pennsylvania, we have documented dogs killing fawns. Some because we know who the culprit was. Other times, a lot of times dogs will kill the fawn, but they won't eat it. So we do have a couple of instances in this last study where dogs did kill the fawns, but most canid predation, you can be assured, is coyote.
Okay, great. Lisa has a question about the predation rates between 2000 and 2015. She's curious if that 70 and 75% is statistically significant difference.
Can you ask the question one more time?
Sure. She was curious if the predation rates between 2000 and 2015, if that's 70% versus the 75%, if that's statistically significant difference.
It is not.
Okay. Then we have a question from Charlie. What is the reproductive potential of the average doe over her lifetime, and how many of those fawns must survive in order to maintain a stable population?
I'll address that one. In terms of the typical doe in Pennsylvania, we're looking at on average 1.5 fawns per doe, but for an individual doe, most likely 2 once she's 3 years old and older. So she's producing 2 fawns on average. We know from our survival rates that about half of them survive. So there's 1 fawn surviving each year. In terms of over the course of her lifetime, our does tend to be older. In terms of average age, we have had does that we've documented out to 14 years of age. So a doe basically needs to replace herself to maintain that population. And in Pennsylvania, that is happening more often than not, where our does are living for multiple years, raising many fawns over the course of those years. So we don't have that issue in terms of, do we have enough reproduction? We have more than adequate reproduction. That's why we can sustainably support the deer harvest that we have in Pennsylvania each year.
All right, thanks, Chris. Okay, next question. This is about the predators that were caught on camera, but more importantly, the ones that were not on camera. So they're curious, how did you know that these animals were present when they weren't captured on the camera? How were you able to determine that?
So we basically just put the detection information into these models called occupancy models. And what these models do is take this detection information, take the number of sites that a species was detected at by the camera. We got a picture of it on camera, and it estimates this thing called detection probability. So the probability that this species, for example, the bobcat, is able to be detected if it's actually at that site. And once you got the detection probability, it's just an easy multiplication problem. You multiply detection probability by the number of sites that the animal was detected at, and you get the number of sites that the animal was present at, but you didn't actually see it. Does that make sense?
I think that does. Thanks, Asia. All right. Jason is curious about the percentage of the study area that is had quality, in quotes, fawning cover. I'm guessing he means good quality fawning cover.
You want to answer that?
So the research tells us that fawn survival is positively associated with agricultural land cover. So the more ag you have, the more agricultural land cover you have in a study site, the higher your fawn survival is generally, and that's a trend seen across North America. So our southern study areas had, they were both study areas, the north and the south, were predominantly forest. And so in the southern study areas, you're going to see a little bit more agricultural land cover than you'll see in the Susquehannock forests. But again, it's a really small percentage. I'd say about approximately 15% or less of agricultural land cover in those areas. And that's just because we did capture sun fawns in private agricultural land cover areas. But when you look at Pennsylvania fawn survival, just considering that we are a predominantly forested area, we have pretty good, if not higher, fawn survival than other study areas that have a similar amount of forested land cover. So we're sitting pretty good, especially for a forested covered region.
All right. Thanks, Tess. All right. Stephen has a question for Duane. I guess you mentioned at the beginning that fawns are also being taken by wolves and mountain lions, along with bears, bobcats, and coyotes. He wants to know if you're speaking generally or specifically about Pennsylvania.
I am speaking generally. If you look at all the studies across North America, the white-tailed deer has a tremendous range going up into Canada and then all the way down into South America. But so if you look at North America, out in the western states, they do have documented predation to mountain lions and wolves.
Thanks, Duane. All right, we have time for maybe about 2 or 3 more. Who's this here? Kent is curious, why were coyotes only the main predator in one of the study areas?
Well, it's hard to say based why one predator kills more in one area versus another. Black bears have historically killed more up in the northern study areas. And there's a lot of research that goes into why predators kill more in one area versus another. So for example, coyotes might be more successful hunting in forested regions that have a little bit of understory cover, so then the fawns don't have a lot of places to hide. Or coyotes might be more successful when there's agricultural land cover, potentially because they can chase them a lot easier and there's nothing to kind of trip over. So it's really hard to say why coyotes were the #1 predator in the South, but not the North. And so that's the best answer that I can give to that.
All right, don't go away. We have another one for you.
Yep.
You mentioned that the predator population has increased about 40% since 2001. Is that an increase in a specific predator or all of them in general?
That would just be looking at bears and coyotes.
Okay. And then, let's see, Arthur would like to confirm the impact of hunting on deer survival is only 10%?
No, if you're taking that from the 90% survival, that was from the end of one hunting season until the next hunting season. During hunting season, harvest rates will vary by the age and sex of the deer. In general, for adult bucks, we're looking at 50 to 60% of the adult bucks are harvested by hunters. For yearling bucks, about a third of yearling bucks are harvested by hunters. For antlerless deer, 15%, give or take, are typically harvested by hunters. But the 90% survival that I referenced in the webinar was from the end of one hunting season to the beginning of the next.
All right. Okay, I'm just going to do two more here. And then for anybody that we don't get a chance to answer today, you can email your questions to this address, pgccomments, COMMENTS, @pa.gov, and we will attempt to get them answered from there. Again, that's PGC, like Pennsylvania Game Commission, comments, COMMENTS, @pa.gov. Okay, so somebody wants to know how you guys picked the camera locations.
We had a spacing design set up, so we wanted the cameras to be about 1,500 meters away from each other. So I plotted random points over the study sites in a program on the computer and basically drove out to the nearest area I could get to that point and set it up in a good spot.
Okay, and then the last one, would you expect there to be different results in eastern and western areas as opposed to north and south?
I'm assuming they mean Pennsylvania, eastern and western Pennsylvania.
Let's go with that, yes.
Yeah, so obviously we haven't studied fawns there, but I would suspect we would get similar survival rates, although surely the causes of mortality would differ. In areas with higher human density, I would expect to see more human-related mortality and more predation in areas where there's fewer people. But we found Tess's research looked at studies all across North America, and as she mentioned before, there is a relationship between the amount of ag and survival, and so that's probably a more reliable predictor of what you would expect to see survival to be, given that most of Pennsylvania is 60% forested. I would expect to see survival to be pretty similar across the state, but just differing by the types of mortality.
Okay, thanks, Duane. Can you remind people how to get to the Deer Forest blog?
Sure. The Deer Forest study is related to this fawns research and predator research, but if you go to ecosystems.psu.edu/deer, you can find out more information about the Deer Forest study. We also have a series of blogs that complement this webinar very well that people might want to look at, and there'll be more information coming out about our research on that blog. So the website again is ecosystems, ecosystems.psu.edu/deer.
All right, thanks. Does anybody else have anything they want to add here before we wrap it up? I'll take that as a no. All right, folks, well, we're sorry we didn't get to everybody's questions. We'll try to get to them through email as we're able. The session has been recorded. You should receive an email with a link to the recording within the next few days. The recording will also be uploaded to the Game Commission's YouTube channel. You'll be able to watch it from there. I'd like to thank Chris and Duane and Tess and Asia for sharing their expertise and time with us today. We'd also like to thank all of you for taking time out of your busy schedules to join us this afternoon, and hope you'll visit us again to learn more about Pennsylvania wildlife in upcoming webinars. Let us know what subjects you'd be interested in seeing next. Thanks a lot, and until we see you again, I hope you're able to get outside and enjoy some of Pennsylvania's great outdoors.